came across this problem in one of my old books off my shelf back there. I think the book was like from the 1920s or 1930s, but I came across this problem and I wanted to share it and give it a shot and just go through my logic of how I would go about solving this. And I'm curious to see if you have a much different approach because it's kind of a weird question. Let's take a look. Something in my pen. It says, Kirsten and Peyton run races of 400 yards. In the first race, Kirsten gives Peyton a start of 40 yards and wins by 12 seconds. In race 2, Kirsten gives Peyton a start of 10 seconds and wins by 50 yards. What are their speeds? So I don't know if this is like borderline, like brain teaser type of question, but it is kind of weird because we have this scenario where they're running a race of 400 yards. In the first race, we have, so let's just break this down. So race 1, and then we have a second race here. We have two races. We have two different pieces of information. So in race 1, Kirsten gives Peyton a start of 40 yards. So we're going to use distance equals rate times time. Now, here's what I'm thinking about this. Since we're giving Peyton a start of 40 yards, we're going to call Peyton's distance 360 yards, and I'm going to call Kirsten's distance 400 yards, because it really doesn't matter the distance, really. Like, give them a start of whatever amount. If we're really only comparing, all right, so you got a 40-yard head start, so now I'm starting, right? So I don't think that we need to consider Kirsten and Peyton's distance both of 400 because this information is being compared when they're both running. So the rate, in the first race, Kirsten gives Peyton a start of 40 yards and wins by 12 seconds. In race 2, Kirsten gives Peyton... Okay, so that's race 2. So let's just focus on race 1. So in race 1, we don't necessarily know their rates, but we know the time. So if we call time for Kirsten X, Peyton took 12 more seconds because it says Kirsten gives Peyton a head start of 40 yards and wins by 12 seconds. So Kirsten finishes, Peyton's still running for 12 more seconds. So we're going to call the time here X plus 12. Well, if I know distance and some sort of version of time at least, then I could solve for rates. So if I have, let me just solve the distance formula, distance equals rate times time. Then I could just solve for rate by dividing by time. So rate equals distance over time. So that means my rate here is going to be 400 over X. And then this is going to be 360 over X plus 12. So let's just move to race 2. Let's see if we can put together some information for race 2. So in race 2, Kirsten gives Peyton a start of 10 seconds and wins by 50 yards. What are their speeds? So in race 2, Kirsten gives Peyton a start of 10 seconds and wins by 50 yards. So 50 yards this time. So let's visualize that. So Kirsten runs 400 yards. And then finishes. How far has Peyton gone? Well, if Kirsten won by 50 yards, that means the 50-yard difference there, so 350. So we don't necessarily need to think of Peyton finishing the 400 yards and then we compare. We're saying, all right, at 400 yards, Kirsten's done. What is Peyton doing? She's at 350 yards. So we have Kirsten's distance again is at 400. Peyton's distance is at 350. What else can we formulate here? It says Kirsten gives Peyton a start of 10 seconds and wins by 50 yards. So 10 seconds, so that means Kirsten ran for X again, and Peyton ran for 10 more seconds because she got a head start of 10 seconds. And then we can do the same thing for rate. 400 over X, and then 350 over X plus 10. I have these two races of information, and I have two different tables. From here, what I can do is, if I take the rates of Kirsten, like this, so they're running the same rates. So we're just looking for their speed. We're assuming it just says what are their speeds. It's not saying what was their speed in race 1, race 2. We're saying that they're going to run the same speed, but there's different stipulations of in this race. In the first race, Kirsten gives Peyton a head start of 40 yards, where in this race we get a head start of seconds. So we're still running the same pace though, the same rates, but we're given two different like head starts, which means that the rates are going to be equal to each other. Now, on the way I formulated this, though, if I set Kirsten's rate equal in race 1 equal to Kirsten's rate in race 2, that's not going to do anything. because it's 400 over x. Look at this. 400 over x in race 1 equals 400 over x in race 2. We know their rates are going to be equal, like Kirsten's rate is going to be the same rate in race 2, but ran the same distance, so nothing's really going to change there. So we can't really do that. But if I take Peyton's rates in race 1, that's 360 over x plus 12, and set that equal to the rate in race 2, because we're given some different information, because in that one, she got a head start of 10 seconds, won by 50 yards, so we got a different distance, and some different seconds, amount of seconds there. So x plus 10. Now we can do something with that. We can solve that. So now we're just solving an equation here. So let's just go ahead and do that. So this is going to be 360 times x plus 10 equal to 350 times x plus 12. So we need to solve this now. So 360 times x, 360 times 10. So 360x plus 360 times 10 is going to be 3,600. Equals 350x. 350 times 12 is going to be 4,200. Okay. Subtract 350x. We get 10x plus 3,600 equals 4,200. Subtract 3,600. Nothing too crazy happening. So 10x equals 4,200 minus 3,600 is going to be 1,200. Sorry, 600, because plus 6, I was thinking of 6 times 2. 600 divided by 10, x equals 60. Okay, so we get x equal to 60. Now, I don't think that's going to really, what does that like tell us? You know, what is that actually giving us here? So let's take a look. So that means x is equal to 60. So if we just go ahead and plug that back in and then start to translate what that means. So x equals 60. So in race 2, for example, let me do a different color here. In race 2, x equals 60, so that means Kirsten ran for 60 seconds. So the rates then would be 400 over 60. 400 divided by 60 would be 6.6666 repeating. So Kirsten's rate is 6.6 seconds repeating. And what are our units here? Yards per second. And then that means that Peyton ran for 70 seconds in race 2. And we can do 350 over 70, which is going to be 5. So Peyton's rate is 5 yards per second. And if you were to even take the other equation, same thing would happen. We can do 360 over 72. Yeah, 60 plus 12, 72. So 360 over 72 is still 5, so 5 yards per second. Yeah, really interesting question. Really interesting question, because the way I set it up, at least. Now, you could probably set up a system of equations and solve the system of equations that way. I just think that my logic is leading us towards this, of just setting up 2 tables and then just noticing, well, we're running the same rates, so we can set them equal to one another. But since I'm using information based off of like Kirsten's starting point of x, and then formulating an equation from there, like formulating an expression of, well, if Kirsten ran for x seconds, then Peyton ran for x plus 12 seconds in race 1. If Kirsten ran for x seconds in race 2, then Peyton ran for x plus 10 seconds in race 2. And just going from there, and I think that helps us out. So this is what I'm going with as the time. Again, I'd love to see some other methods of solving this one, but I think that's a really good problem-solving scenario, and definitely one that I had to think about for a little bit when I saw it, and I thought it was interesting enough to throw it up here on YouTube. So let me know.